Welcome to my first video of a couple of videos that I want to do on my next project, which is going to be building the second generation of my e-paper smartwatch that I built last year. So this is version 1. It has an e-paper display and a custom PCB inside, which is this one here. And I want to upgrade it. For this one I used the ESP8285, which is the smaller version of the ESP8266 here on the D1 mini board. And I decided to go with an ESP32 because a lot of people requested to have Bluetooth in the next model, and so the smallest ESP32 module that I could find is this TTGO Micro 32. What I'm going to do in this video is I will create a footprint for this in KiCAD and create a breakout board so I can use this to create the first prototype and see that everything works. I created one for the ESP8285 and then reused the footprint to create the PCB that will go into the smartwatch. So this is the PCB that's sandwiched in the inside of this one here. This is the screen that you will see when you create a new project in KiCAD. KiCAD is a cross-platform and open source electronics design automation suite, which means we can create schematics and PCB layouts, and we can view the result in the 3D viewer. You will find the binaries in the download section, and I think they got everything covered to installing it and getting started with it. So where do we start? I know I have this tiny module, and I'm pretty sure that there's no footprint for it. Let's check first. I found this thread here on GitHub where someone actually created one. So we have luck. So creating a footprint will not be part of this tutorial, and we're going to save some time. I think I will create my own in any case. First we need to create a symbol. Start by opening the symbol editor and select our own symbol library and click on the create new symbol button. So the symbol's name will be TTGO 32 micro. Leave all other settings on default and we will get this view here. You can move those labels by hovering above them with the icon, then hit the M key and then just move them away. If we look at the module, we will need to get the names of the pins. So next step is to get a description of this module. So if you do a bit of searching, you will eventually find an image that will look kind of like this, and we will use this as a reference to create our symbol. So we got all the pins labeled here for the module that we're using, and we're going to create those pins in the symbol as well. We do this by clicking on the Add Pins to Symbol button here on the right hand side. You click it, and you click to add it, and we're going to name the first one GND for ground and give it the pin number 1. The orientation right is the correct for the left hand side, and the electrical type we will set to power input. The next one is 3.3 volts, so 3V3. It gets this name, pin number is 2, power input is also correct. And then we're going to repeat this for the other labels as well. To make sure that your symbol is nicely flipped and rotated, you have to make sure that it's centered around those 2 blue lines here. Next I will do those bottom pins. So I'm going to add 8 pins at the bottom. The orientation is top. Pin number is 16. And we will have to add the same amount of pins on the right hand side. The orientation is left, and we'll continue counting up. This one is not connected, so we'll also set the type to not connected. Then I'm going to make sure everything is nicely centered. Then draw a graphic rectangle for the symbol body. This is not looking nice yet because it's too narrow. The easiest way to move things is to use the arrow keys. And then draw the body. And we've created the symbol for the TTGO 32 micro module. We save it and close the symbol editor. Now we have to create the footprint. To create the footprint, you need some details about the dimensions of the device. By googling a bit and using the image search, I found this, so we can use this as a reference. First, I'm going to set an active footprint library, which is my custom library, which I call footprints, and then click the new footprint button. We'll give the footprint the same name as the symbol before, TTGO 32 micro. Hit enter to confirm. Zoom out a bit. This is where we will get the footprint. Similar to the symbol, we will add the pads first and then draw the surrounding parts. By looking at this thing here, we will see that the pads have a distance of 1 millimeter each. So by measuring, I'm guessing the pads are 0.75 millimeters wide, and I'm guessing we can make them about twice as long. Back in the footprint editor, I'm going to click on the Add Pad button here. Again, we'll start in the top left corner, we'll add the first pad. Hover above it with the mouse, hit E to open the properties editor. Change the pad type to SMD, the shape to rectangular, and size X to be 1.4 millimeters. And I'm going to use 0.762 millimeters as its height. So the location of this pad should be, if we look at it, it has a width of 30 millimeters, so minus 7.5 millimeters. And the Y position to have it centered should be minus 7. So this is where it is now. We'll add the next pads by clicking on the Add Pad button. It counts the pad numbers up, and we'll just add the 15 pads on the left first here. Now we have 15 pads, and we're going to edit those locations a bit first. Now that we have the left row of pads positioned, okay, Control 0 to center everything, drag to select them, then right click to get the menu and hit duplicate, and then use the mouse to move them all the way to the right, more or less to the location X 7.5. We can select the pads on this row and then hit align to left, and they're all at the right position. You can do the same with this pad, edit it, go to minus 6.5, select all the pads on the left hand side and align to right. At the bottom pad, we need 8 pads, 2, 3, 4, 5, 6, 7, 8. After I added the bottom pads, I will make sure they have the right location, so this needs to be the Y position 9.45. We'll fix this here, it is already fixed. And the X position needs to be, in this case, minus 1, 2, 3, 4, but sentence, so minus 3.5, as well as this one. Now we can select all those pads, distribute them horizontally, align them to the bottom, and they're in the right place. What next? We will add the outline. Select the silk screen on the right hand side. So I'm going to add a graphic line. We will need one line here on the top. The location needs to be minus 7.5 to 7.5 at minus 9.45. So we're going to edit the corners. We'll add another line at the bottom, then add the sides. Now this is the outline. I'm going to guess the area where the antenna will be. So I'm going to draw it somewhere here, and a circle here with a square around it to indicate the external antenna. Save it, and we're done. Then we'll do our first test. We will open the schematic editor. On the right hand side we find the place symbol button. We'll click once. We can choose our symbol and we'll search for TTGO 32 micro. We'll place our symbol. Then I noticed I forgot to label the pins correctly, so we will open the footprint editor again. Load a footprint from the library. We'll search for TTGO 32 micro. To renumber the pads, you can right click, go into pads, renumber pads. First pad number will be 23. Hit OK and then click on the pads to rename them. And then double click to complete it. Okay, I clicked too many times on this one, but here we go. We'll have 37 pins. We can save again and go back to the editor. So I just noticed I have a bug in here. 1, 2, 3, 4, 5, 6, 7, 8, 9. This. Uh-oh. I missed the pin here. This is only 7 pins. Crap. So and we're done this time, hopefully, finally. In the schematics editor, you have to click on annotate schematic symbols. I usually leave it at the default settings, hit annotate. It gets named to U1. Then click on the assign PCB footprints to schematic symbols. I select my footprints library here and select by double clicking this footprint to this symbol. Click on the net button and then click on generate netlist. Save it. Go into the PCB view. Load the netlist. Hit on read current netlist. If there's no errors, you can just place the component and we have it. So what I'm going to do next is I'm going to print this and put the module on top of it to see if it aligns. So go to the file menu and hit print and just select the font copper layer because we're interested in the pads. Everything else is not important for this test. And then it's important, before you hit print, make sure you have selected accurate scale 1, and then you can print it. So this is our print result here. I will check if this footprint makes sense. So as you can see here now, the footprint should align. But if we look at it from the top, we see that the bottom row is a bit too low, so we'll move it up by 0.5 millimeter. Let me check with the values. This is our updated footprint. You can place it on top again and see that we have a really nice match. Before I continue in KiCAD, I'm going to look at this breakout board. These two modules here, you will see they have exactly the same width, which leaves us with a row of pins on the sides. As this module is a little bit smaller, we could go narrower, but not doing so gives us more space when routing the pins to the pins that will go onto the outside. Back in the schematics view, I'm going to add 3 rows of pins. Click on the place symbol button. Now I'm going to search for the connection pins. I want 1 row of 15 pins. the left hand side, and we can duplicate it for the right hand side, and also add an 8-pin row for the bottom. The quickest way to find them is to type in con_01x08. I'll just use the generic ones, rotate them by hitting the R key. In this case I'm going to flip this one. Orientation, mirror around the vertical axis. And we can connect them with wires, hit the W key, and it will start drawing wires. Annotate the schematic. Now we need to find the right connectors, and it already suggests us connectors by the number of pins that this symbol has. If you're not sure which one to take, you can preview this footprint by selecting the view selected footprint. You can see this is the row of pins, this should do, and it's a 2.54mm pitch, which is exactly the pitch of this thing, and we can select it. Hit OK to leave it, then generate the updated netlist. Go into the PCB view again, load the netlist. Yes. And just place them somewhere first, and then move the rows into location. Now, this is going to be a bit longer, so we'll place those here as well. Maybe rotate it so we have no crossing lines. Next, I'm going to change the grid to 2.54, so we can see a dot every 2.54mm, and move those accordingly. So the distance here is, this breadboard is 10 pins. To align them, just put them on top of each other, grab the right one and move it by 1, 2, 3, 4, 5, 6, 7, 8, 9 places. Move the micro in the center again. We can change the grid layout, grid alignment now to something smaller, so we have a smoother alignment. This should look symmetrical, and also this line here. I'm not happy with this thing because I want to reduce the size of the footprint, so I will go back into this view, remove this, and add 2 4-pin connectors and move them up such that it connects with the wires. Assign the pins, reload the netlist after deleting the change component, and move those to the sides here now, and then align them. Now you see those square pads. We want those to be circular as well. Select the pad, hit the E key, and change it to be a circular pad. We're going to use a grid that should align with our pad, so we'll go with something around 0.5 mm here. So we're going to draw the wires. I've set my design rules to a track width of 0.2 mm because this leaves enough maneuvering space to draw a lot of them, especially if you don't have that much space. So when drawing these, sometimes it's the easiest to start with the shortest distances first. So connect those first, and my favorite way is trying to be as symmetrical as possible. and we have all the wires set. They're not perfectly symmetrical, and getting this right is something where you can spend hours on. We're going to select the edge cuts layer and draw a graphic line around this. I'm going to select the font silk screen here and add some text to it and call this the TTGO 32 micro breakout board. What you can do now is, because we'll use this for prototyping and we don't want to look up those pins, add a lot of labels here. Use a size of 1 millimeter and place those here. And I will use left justification so they're aligned to the pins. Let's add some info first. This is revision 1. Let's check if the spacing works out. And it's overlapping with those pads here on this side. So I will try to go a bit smaller. Move it, and yeah, this gives us enough. So I'm going to duplicate it till I have enough of those. Align to left. Then do the same on the right hand side. Add the label, change the justification to the right, move it into the correct location, and then duplicate it and align them to the right. Now we added all those. Let's make a little bit room on the side to view the symbol and rename the labels. So now we did this, let's take a look. The pins are pointing into the wrong direction. I could figure out how to do this, but not now. But you'll get the idea. And the next step would be uploading it and ordering it.